Well, thank you very much. I'm delighted to be with you this evening, although my message is a tough one. Can we fix it is the question behind the series, and that is really what I'm trying to address. I used to be very optimistic about our ability to fix it. My optimism is becoming a little bit tarnished at the moment, but let's see how we go. So my first piece of what I say is going to be just to take you through the climate science that many of you know, but just so we're all familiar with the points I'm making. And the other side to this story is, in a way, a personal saga. My time going into government with Tony Blair was the beginning of the British government taking what I will describe as the leadership role globally on the issue of climate change. And so I will be spinning that out, my personal story around this, and then taking you to Paris and beyond. And it's the beyond that is the real challenge now. So let me then summarize what I'm going to say, which is to pinch a line from the latest Intergovernmental Panel on Climate Change report. I believe that what we do now and what we continue to do and what we prepare to do over the next 10 years will determine the future of humanity for the next few thousand years. So we've got a very short timeline now to act, and to act quickly to manage this enormous challenge. Now that sounds like a very big statement, and I'm going to spend a bit of time trying to justify that. So first of all, let me start by pointing to the very important set of data that has been obtained from ice cores in the last few decades. And this is data which shows carbon dioxide levels average in the atmosphere going back 400,000 years, and global temperatures. Also obtained from ice core data, the same ice cores producing the same set of data, but also at the top, the carbon dioxide concentrations. So so we see global temperature, carbon dioxide concentration, and sea level at the bottom. And it doesn't take too much to see that there is a correlation between all three of those. When the carbon dioxide levels are high, and by high I'm talking about 270, 280 parts per million, we have always been in a warm period. And when they're low, 180 to 200 parts per million, we have always been in an ice age, at least going back 1 million years. So there's the correlation. Correlation is not causality, let me stress that. There's many feedbacks in the whole system. It's much more complicated than simply to say this is causally related. What comes first, the CO2 or the temperature rise? These things are totally interrelated. And the sea level rise is critically important because, of course, when the temperature is high, ice on land melts. It has to go somewhere. It ends up going into the ocean, and so the ocean sea level goes up dramatically during the warm periods and then comes down again during the ice age as water from the oceans percolates onto land as snow and is collected as ice on land. So these correlations, critically important. I'm going to say sea level rise is Britain's biggest challenge. And I take you back to the period when I was in government. The first thing I did coming in as Chief Scientific Advisor in the year 2000 was set up a foresight program, an in-depth program, looking at what we knew from climate science was the challenge of rising sea levels going through the century, and what Britain's response to that should be. It took 3 years. We had 120 experts working on this over that time. And when I reported it to Parliament, I was basically saying, if we don't act, so business as usual, we're going to find it extraordinarily difficult to defend our cities, to defend our coastlines from attack. And one of the biggest problems here is that when there are storms at sea, there are also storms inland. We are an island nation. And so the rivers are in flood at the same time as the coastlines are under attack. And we set up a series of programs as a result of this. I must tell you, I was asked to present this to a joint meeting of the two Houses of Parliament, House of Parliament, House of Lords, and it was a completely filled room. And people were quite taken aback by being shown a picture of the islands of Britain out to 2080, showing their constituencies going underwater. Right? So it was quite a wake-up call. But of course, what we were saying is that there are two actions required. One is we need to lead globally on the campaign to reduce emissions. And the second was, and we need a system to manage flood risk for the United Kingdom. And we started putting that in place in the year 2003. When the big floods came, 2012-13, we had already put in place a large portion of our defences. And those defences were based around a very simple principle, which is defend your major assets first. So Londoners were completely unaware of the flooding. All of the floodwaters coming down the Thames were turned back up the Thames, and it was the Prime Minister's constituency that was flooded rather than London, this being not quite such a major asset. So the point about this is that we declared these areas as floodplains. We actually asked there should be no building permission in those floodplains. Local authorities didn't always follow that. So let me move on. Flooding is our big risk, but of course rising temperatures and other challenges are with all of us going forward in time. But that is my explanation as to why it is that Britain put a very big effort into this. So how do I measure the effort? We put 165 climate attaches into our embassies around the world. We were still, by the time of Paris, the only government with full-time climate attaches in all our embassies. And we set up an international climate fund, which was entirely funded by the British taxpayer. You may not know this, but that fund was initiated in 2010 at £4.5 billion, and then another 4 billion was added in September 2015 in the run-up to Paris. So when I moved into the Foreign Office as negotiator, I had enormous power. I had the depth of the money to back up the negotiations, particularly with developing countries. And by that time, we had our action that in 2008, Parliament passed with no party voting against it, only 3 votes against, the Act of Parliament on Climate Change, and that commits all future governments from 2008 onwards to reduce emissions by 80% by 2050. And we're closing in on 46% reduction today. So all of these actions took place. Not much is in the public domain. And please ask me why not, because that's quite an important question. So now I want to just come back. This is a very rough background I'm giving you here. In 2003, we had the biggest challenge that Central Europe has experienced in terms of lives lost. And this was a heat wave. It wasn't described as a catastrophe, but it was. It took place over 6 weeks in the summer of 2003. The estimate is about 50,000 people lost their lives in that big episode of high temperatures. And what I show you here is temperature on the vertical scale, and on the horizontal scale, time going back to 1900 to 2100. And what I'm showing you in black is the average central summer European summer temperature. From 2003, that is marked with a cross. Let me just walk up to it. So this cross up here, and in black is the average Central European summer temperature going back in time. And I asked the Hadley Centre at the Met Office to run their programs backwards in time, just for Central Europe, and without changing the parameters in their programs, to see how well their program would describe the variation for Central European summer temperatures. And you'll see it in red. The program is reinitiated 3 times 6 weeks apart, and I'll explain that in a moment. But you've got 3 red curves. The red curves are all theory, going back in time to show that we've got some confidence in the model, and then going forward in time on a business as usual, a medium to high emission scenario. Now what you can see if you extrapolate along a horizontal line through that cross in 2003, when we get to 2045, the prediction was that would be the average summer temperature in Central Europe. Right, so when we talk about impacts of climate change, what we've got to remember is the average temperature is only that, it's the average temperature. The severe challenges to humanity are from these extreme weather events, and as the basic temperature rises, the extreme events become much more extreme. So as we move forward in time, what you see is the Met Office's model running with greenhouse gases in it, and I said reinitiated every 6 weeks, 3 periods apart, because beyond 6 weeks, it's very difficult to predict the weather. And what you see looking like noise is the weather, and the trend is then the overall change. And by doing it 3 times, we see that the trend is what is being driven by greenhouse gases in the atmosphere. So that's a very important point I'm making, because we scientists tend to want to predict things very accurately. We don't like publishing papers unless we're very confident. It's the actuaries in the insurance and reinsurance industry who are very good at looking at low probability events and working out what the likelihood is. That's why you can take out an insurance policy against your house burning down. Even though you don't expect it to happen, they can give you an insurance policy that will give you the money back if your house does burn down. And they need to calculate that accurately, let me make this point, because otherwise another insurance company will undercut them, or else if they've already undercut the price, their company may go bust. Right? So these actuaries are pretty clever at calculating these things. Now, I'm going to come back to that. Let me just give you, going back to, yes, this is now taking you back in time, again on the horizontal axis, on the vertical axis we've got temperature, horizontal axis time, and we're going up to 2018, 2017 here. This is just showing the average global temperature rise over that period of time. And this gives another point. Weather is looking like noise on that first graph. Here we also see, in addition to weather, we've got these cyclical phenomena. There might be 10, 20, 100-year cycles sitting on that background. So we're just picking out here the El Nino, La Nina cycles, which means that when we have an El Nino, the temperatures are unusually high. La Nina, temperatures are unusually low. So when you meet a climate skeptic, they will say, look, we can't predict anything. And they will point to all of these cycles. But actually that trend is already becoming extremely clear. And let me say very worrying, because that business as usual cycle, taking us up to temperature rises of the order of 4, 5, 6 degrees centigrade is an extremely worrying notion. Now, when I moved into the Foreign Office, a group of us led a piece of work with the Chinese and Indian governments in particular, and of course these are 2 very important global players, on a risk analysis associated with climate change. This was the first detailed risk analysis to be conducted. And we worked with experts from around the world, but in particular from the Chinese and Indian governments, we had generals, admirals, security service people, and defense force people there. And we worked with them for close on a year, and our report was published on the Foreign Office website. It's still available there. And I always advise people to have a few drinks before you read it, because the message is not a very happy one. Right, so in essence, these are the senior authors, but we had about 120 people in total. This was, for all of us participating in this, quite a sobering experience, because when you do a risk analysis, you're talking about what is a 1% chance of something very severe happening. And we hadn't actually seen analyses going this far before. So having talked to the experts drawn from China and India, we then asked them to go away and come back to us and more or less said, what would you like to take out an insurance policy against? Right, so give us some problems for the actuaries. And they came up with some extraordinarily good challenges, one of which the Chinese brought forward was, what is the probability of all of our rice crops failing in a given year? Now you can see what a challenge that is to the Chinese people. But actually a challenge to the whole world, because China has deep pockets. They'll be on the international marketplace, and everyone will find that this is a dramatic transformation in the way the global economic system works. So in essence, on that particular one, today the probability of that happening in a given year is well below 1%. It's more like the probability of your house burning down. Right? But even a 0.5 degree rise above the present level, and that's beginning to approach 1% in a given year, and then if you take it up 1 degree above the present level, that is getting very serious. So over a 10-year period, it becomes a high probability. So we looked at rising sea levels, and of course, when we look at India, we looked at cities that were most at risk in the world, actually, and Calcutta, we concluded, is the city most at risk. And sitting at the mouth of the Ganges is a dangerous place, because the Ganges is in flood when there's storms at sea. It's the same as the British problem, but multiplied by quite a large extent. And so we predicted that Calcutta would be the first major city to become unlivable due to storms at sea. If we then move across the Ganges to Bangladesh, of course we were also saying this is going to be the first major country that becomes unlivable due to rising sea levels and storms at sea. So this is looking at 160, 170 million people needing to find somewhere else to live, which puts what's happened in Europe over the Arab Spring, all of the challenges we've been faced with moving people and destabilizing our political systems, this is nothing by comparison with this. Both China and India took this program into their own countries after we'd finished. India took it into their security services and defense forces. And of course, with India, that is a major threat to have a neighboring country that is going to produce an extraordinarily large number of refugees, climate refugees. So we could understand exactly what they were doing. China is much more open about what they're doing. They've also continued this for 3 more years, and they bring me in every year to explain how that's going. They're very open about what they're doing. So if we look at this issue of probability analysis rather than prediction, which is what is the most likely thing, I'm just going to show you one graph here, which sets out, in terms of the Intergovernmental Panel on Climate Change notation, I'm not even going to spell it out, RCP 2.6, that would be the best possible behavior where we've reduced greenhouse gas emissions as much as we can. At least that's what the IPCC used to think. And the red curve is the other way around, where we're just carrying on business as usual. And we're looking at the probability in percentages of the temperature rising above 2 degrees centigrade for these different behaviors of greenhouse gas emissions going forward in time. And you can see that those curves all kick off before 2030. So we are looking at something that is imminent here. And if we take the red curves, then by the time we get to 2050, we're saying there's a 100% chance we will exceed 2 degrees centigrade. But I just want to point out the best behaved curve, and this is why I need to move you on to climate repair, is the blue curve. And the blue curve is saying the chances of exceeding 2 degrees are only 35%. But let me turn that only around and say, my goodness, we are putting our future of humanity at a very significant risk, because 2 degrees centigrade above the pre-industrial level has many, many ramifications for our mode of living in the future. So I'm actually saying the blue curve is inadequate. And of course, the second thing I'm saying is, and we're not even close to getting there. So now let me take you on to Paris. I need to make a statement, because there have been many lectures in Christ's College recently, and organized by Charles Kennel, who is American, and I just need to make a very general comment. In all the negotiations that I was involved in, from the time of the Blair government right through to the May government, I left in March 2017, the biggest thorn in the flesh of the international negotiators was the United States contingency. There was only a 4-year period, the second period of Obama's period in office, when that wasn't true. So at the negotiations, the COP meetings, each country has a large contingency. Britain, maybe 40 people, but the United States, about 160. And from the Bush Jr. group up until Trump today, their 160 people are going around persuading the delegates that this is just not worth the candle. And that has been happening over all of this period of time. And the second thing is, the nature of the agreement we reached in Paris has a weak side to it, because it's not a top-down agreement. It wasn't the United Nations saying to each country how they should cut their emissions back. It was inviting each country to make their voluntary contributions to reducing emissions. Now, why was that? Very simple. Because we knew without that allowance, the United States could not possibly sign. So even though Obama himself, the president, was all for action, he didn't have Congress or Senate behind him. He didn't have more than half a dozen votes in Congress or Senate to back signing up to an international treaty on climate change. So we have really had a very tough time over this period. And so when we point to the weaknesses in the Paris Agreement, I just want to say, bear that in mind. People would say to me, but the Kyoto Agreement was faulty. When we worked in the British government, we could see the Kyoto Agreement wasn't nearly good enough. And so we made that unilateral declaration that we would reduce our emissions by 80% by 2050, because we wanted to go much further than Kyoto. We wanted to give this as an example to every other nation as to how we should move forward in time. Now, that I think is very, very important to understand, because we finally get the Paris Agreement, and it was a major step forward. And I'm only pulling out what I consider to be the 3 major elements of that agreement. The first part of it is the overall long-term goal. That is, overall, when you add up the behavior of every country in the world, we were saying we have to achieve a temperature rise which is globally less, very much less than 2 degrees centigrade above the pre-industrial level, and to pursue efforts to limit the increase to 1.5 degrees centigrade. Now, I'm going to just very quickly tell you that it was the British government who pushed that 1.5 degrees centigrade together with the small island nations around the world. And this was simply done because we too are an island nation, and rising sea levels is the big threat to those island nations and to us. And so moving that 1.5 degrees centigrade not only into debate but into a decision was crucially important but also very challenging, because everyone was already saying, but 2 degrees centigrade is already too challenging. We can't achieve that. So how can you put forward a 1.5 degree scenario? So that's the agreement. Let me just now show you a simplified diagram of what we are achieving at the moment compared with business as usual. So baseline is what I'm calling business as usual. The yellow, current policy trajectory. The red and the green are these nationally determined contributions all added together. The conditional nationally determined contributions are developing countries saying we can do this extra work if we get more money from the developed countries. And you can see that the green, the red and the yellow curves are all far too much emission compared with where we need to be on the 1.5 degree centigrade range, or let alone the 2 degree centigrade range. There's the challenge we're up against. And I'm showing these curves, although I believe they're over-optimistic. So the 1.5 degrees centigrade, if we want to be more than 50% sure, and remember 50% is not very good going forward in time, that we get to below 1.5 degrees centigrade, we need to be getting to net zero emissions by 2040. Right, so there's the challenge. 2040 is just around the corner. While I've got this slide on, what it's telling you is vertical axis, billions of tons of greenhouse gases emitted as measured by the carbon dioxide, and then in time 2010 to 2050. Now, we can see that our mitigation behavior, that is reducing emissions, is really not even close. But even if we do manage the mitigation program, let us say to stay on the purple curve, even if we do manage that, we're not nearly safe enough. And I'm going to explain that as I move forward in time. Let me just stay with the mitigation debate. Mitigation is all about reducing emissions. We're not going to survive this thing if we don't get our emissions back down from the 50 billion tons a year to net zero. Right? So we need to be looking at how we achieve that. And in the run-up to the Paris meeting, in a note of optimism, I wrote this editorial that was published in Nature. And the editorial says, there's the headline, biggest opportunity of our age. And what I'm referring to is the fact that the energy systems of the world is quite simply the biggest piece of the world's economy. And if we're now undertaking a transition from all of our energy, or most of it coming from fossil fuels, to no fossil fuels, the opportunity is represented by the new technologies that are needed to be brought into the marketplace. And that opportunity, we were estimating by 2020 is a minimum of $1 trillion a year, the opportunity for new energy technologies. Now, what has proved quite remarkable, and I can take you back in time to that period when I was in the Blair government, when the government introduced effective feed-in tariffs. We could put photovoltaics on our rooftop and we were guaranteed a price for any electricity we put onto the grid from our own photovoltaics. And that operated in Germany, Spain, Italy, right across the European Union, and we were very effective in pushing that across the EU. And the net result was a big surprise to most economists, and that was the massive fall in the price of renewables. As the marketplace expanded to meet this artificially generated demand, as the marketplace expanded, you drew in more and more competitors, you drew in more and more new technologies, and prices kept falling. And I just show you one curve, which I've called Swanson's law. It's a logarithmic behavior, where you bring down the cost of installation of photovoltaics on a logarithmic function with the cumulative demand for those photovoltaics. And so we're now seeing photovoltaics as price competitive for producing real-time electricity on grids around the world between the tropics. Wherever there's a fair bit of sunshine, this is now very competitive with any fossil fuel energy system that could be brought to play. Now that's critically important, because then the marketplace really pulls it through, because every country will want to install renewable energy provided we've got some missing technologies. And one of the missing technologies is energy storage, right? Because these are intermittent sources. So just moving forward, do we need more radical technological innovation? The answer is yes, but we need to target the innovation support. So here's the background to that statement. In 2015, this is the year of that Paris Agreement, already the turnover in renewable power was up at this figure, $367 billion. That amounted to more than half of the world's new energy provision for electricity generation for the whole world, more than half. That was market penetration due to competitiveness. Right? It was driven in some countries initially by these feed-in tariffs, but then it became competitive. And many of you will know that if you go into the developing world, if the grid is not extended to every village, it certainly isn't in India and Africa, it is far cheaper now to create renewable energy sources in those small villages without the grid being run to them. It is 2 to 3 times cheaper than extending the grid and using the large-scale energy production systems. So we can see the advantages already flowing from all of this. But I've already indicated we don't have all the technologies to run to 100% renewable energy. And what I'm now coming to, it was a little bit of a personal triumph. About 7 years ago, I began working on a program to encourage countries to join together and invest public money into the development of all the missing technologies that we need. So in other words, public money going largely into our universities to raise the level of research into clean energy technologies. The idea materialized in terms of countries qualifying to join the group if they promised between 2015 and 2020 to double their investment in new clean energy technologies. And there's the triumph. On the first day of the COP meeting, when the heads of governments were all there, we had this picture taken under that Mission Innovation sign, which is the name of the program. And so 22 heads of government were there. You will see Obama in the middle. But you will see somebody else there who isn't a head of government. Bill Gates is up at the front. And Bill, that is certainly the most strange telephone conversation I've had, was with Bill Gates saying, wonderful idea. I'm going to put $1 billion of my own private money down, not philanthropic money, to take the new technologies that are developed in the program into the marketplace. And that's, of course, exactly the purpose of the exercise. It was to use public money to de-risk the new technologies to be taken by the private sector into the marketplace. So This venture took off when Obama was finally persuaded in September 2015 to back the program. And then all the other heads of government that are standing there joined the program. There is an interesting effect in the political system. When a major figure takes a leadership role, others want to get in behind. And you will see David Cameron is there in that list. What has emerged? Well, here's a way of storing energy. And I'm showing this to you. This is a company in Germany led by a mining engineer, Professor Heindel. Heindel Energy is producing this system, and what I'm showing here will store about 1 billion watt-hours of electricity. So we're talking about grid-scale energy storage. And it's using a very simple and well-known technique, which is up-pumping water. But normally you would up-pump water several thousand meters into a reservoir when you've got excess electricity, and then run the electricity through a hydropower station to generate electricity when you need it. This is exactly the same principle, but it can be used for a flat piece of land. And all it is using the granite below the land, carving out a cylinder of granite out of that granite that is in situ there, and that, by the way, using standard mining techniques. And then you up-pump the cylinder of granite with water when you've got excess electricity, and then allow the cylinder to drive water through a hydropower station to generate electricity. So this is a very effective energy storage technique, which is now the first machine is being constructed, interestingly, in Saudi Arabia. Saudi Arabia is planning to provide all of their electricity from solar energy, and what they needed, of course, was energy storage to see that they've got the lights on at night. So it's one of the solutions that is emerging. I'm giving you one other example. This is actually my favorite. It's a British company called Varialift. And Varialift have developed the airship into a new principle. So you see an airship here, and this airship has got an aluminium frame. That's really what is different. And within the airship's aluminium frame, there are 12 compartments. So it's learnt the lesson from the Titanic. If one compartment is holed, it's still got 11 more compartments keeping it up. Inside each compartment is a helium bag, a helium cylinder, and a compressor. When you want to lift this up 30 to 40,000 feet, it'll go. When you want to lift it up, you release helium, of course, into the airbags. When you want to bring it down, pump the helium back into the cylinder, and down it comes. This is designed for taking freight. Underneath the aluminium frame, you see the blue container. And that blue container, this is very large, by the way, 175 meters by 75 meters. 175 meters long, 75 meters wide. It's enormous. So the container underneath would take about 20 ship's containers fully loaded. Right? So it's not anything like an Airbus carrying freight. This is carrying far more freight. And if you now take the final point, it's got an onboard crane. So imagine that we want tomatoes from Spain to be brought to our depots here in this country. This would pick up the ship's containers from the ground on the tomato farm areas in Spain into its hold, bring them across to Britain, and then lower them onto the depots of Sainsbury's and Tesco's and all the others. It doesn't land at an airport. It cuts through the need for transportation using road transport at either end. It's a real breakthrough technology, and it is, by the way, this is a Photoshop. But it is close to realization. It was initially being constructed here in the UK, but the French government came up with the offer of an unused large airport north of Paris, and that's where it is being constructed now. Now, it does cost about the same as a Boeing, but the travel costs are massively reduced. The one important thing I haven't told you is that those engines are electric. Because it's so large and can fly at 35,000 feet above clouds, it is covered with photovoltaics. And so it's gathering solar electricity from the sun and is using that to drive the machine. Now, of course, it can carry a large weight. The aluminium frame itself is heavy, but that is an advantage because this sheer size creates this ability to pick up enough solar energy to drive this at a constant speed, unloaded, of 340 kilometers an hour. And at a fully loaded level, it would be about 240 kilometers an hour. This is, I'm an advisor to the president of Rwanda, and he's placed an order for 4 of these. Rwanda is a landlocked country, and what he says is, with these, we become an interlinked country. We're the central country in Africa, and we will be transporting goods around Africa, picking goods up from the ships in Mombasa without landing, bringing them up, and then bringing them over to Rwanda and the rest of Africa. Because the infrastructure on the ground is so minimized, it means that this really is transformational. This is the equivalent of the mobile phone for Africa going forward. So let me move on from my own excitement about the technologies that are beginning to emerge. I've just mentioned Rwanda, and back in 2010-11, working with a group of 8 postdoctoral research workers, we produced a green growth and climate resilience strategy for the country. I'm now spending 15 weeks a year in Rwanda, which is going to be the first fully green country in the world. This is a country where they are planning to move right away from petrol or diesel driven ground transport, right away from generating electricity from diesel, all the way straight through to renewable energy systems. And as their economy is growing at about 8% a year, average for 18 years, it means this is the time to put all the new infrastructure in place instead of going through the old type of infrastructure. It's very good for their economic development because the dollars that were going out for buying diesel to make electricity are now being spent in country. Now, I'm going to switch the discussion a bit, which is, why am I emphasizing climate repair rather than mitigation? And this certainly is a new position I've taken since the negotiations in Paris came to that conclusion. So I'm showing here Arctic sea ice extent over the last nearly 1,500 years. The reconstructed sea ice extent is for most of this curve, and then the direct measurements are the more recent. But what this is showing is that we have been losing Arctic sea ice at a faster rate than has happened over the last 1,500 years. And it's faster than we might initially have predicted because there are positive feedbacks in the initiation of the melting process. And so, why should we be concerned about the loss of Arctic sea ice? When ice on the sea melts, it doesn't raise sea levels. So what is the major concern? Let me explain, but first of all, just to back that up with some pictures taken same day of the year in 1980 and 2007 of, in purple, the remaining sea ice. So the Arctic, this is summer sea ice. The Arctic Sea is being exposed more and more in the summer, and the sea, dark blue, has a propensity to absorb a high percentage of the sunlight that falls on it, whereas the ice reflects a high percentage. So this big change in the so-called albedo is what is really the positive feedback in the loss of Arctic ice. If I just show you now a couple of graphs, average monthly Arctic sea ice extent, 79 to 2018, and you can see it's dropping in quite an alarming way. I'm now going to switch to the Arctic sea ice volume, and you see the same picture there. I'm just going to show now Arctic sea ice volume, which is really an adapted figure from Peter Wadhams, who was at the Scott Polar Research Institute. Peter painstakingly measured the thickness of the ice above the Arctic Sea over the period back to 1980. And all of this is indicating this very, very dangerous effect. Now, why do I say it's dangerous? Let me just first of all say this is Arctic winter temperature anomaly. So what is happening in the Arctic region because of the exposure, the greater and greater exposure of the Arctic Sea during the Arctic summer, the average temperature is going up. This is just the winter temperature anomaly, December through February, which you'll see is about a 4 degree centigrade rise compared with the rest of the planet, which is at about 1 to 1.1 degrees centigrade rise today. So the Arctic is heating up considerably faster. If I showed you, and I haven't got it here, the average through the year, it's more like 2 to 3 degrees centigrade. In other words, 2 to 3 times higher than the rest of the planet on average. All right, so what are the consequences of Arctic warming? So first of all, right next to the Arctic Ocean that is being exposed in the Arctic summer is Greenland. And of course, the ice on Greenland, which has been accumulating since before the last ice age, that ice, if it all melts, the sea level globally would rise by about 7 meters. So the melting of the Greenland ice sheet is itself a very big challenge to the whole of humanity. And that is beginning to happen. And of course, we've got to expect this to accelerate, sitting next to the warming Arctic sea, but also the mode of melting is not straightforward. It's not like a block of ice you take out of the freezer and put on a saucer on your table. It doesn't just melt uniformly. It does tend to form lakes on the surface, and as these lakes deepen, they get bluer, they absorb more sunlight, and so we get another positive feedback. In the middle of this graph, picture, we see the meandering of the polar vortex. Now, the polar vortex is a roughly circular wind that tends to keep the cold air in the Arctic region, and that is distorted. It's always been somewhat distorted into this kind of sine wave function that you see here. But this year, that vortex has become split in two over January, February. And the splitting of the vortex is creating these strange anomalies where Chicago is much colder than the North Pole. I was talking in Dallas, Texas, where the temperature a week before I arrived in Dallas was minus 15 degrees centigrade. And the Texans were wondering what on earth was going on. Well, I showed them these slides produced by the Met Office, and it then becomes apparent to them that they haven't had this explained in their newspapers. And by the way, nor have we. So I'm not saying that this distortion, the meandering, is directly related to climate change. I cannot say that because there's still a lot of work to be done to prove that point. But nevertheless, it looks very likely that that is the case. And then on the right-hand side, we know that in many parts of the northern Russia, for example, or northern Canada, where you have permafrost. In many places, you can throw a match on the ice and it'll burn blue. It's methane emerging from the ice, and the permafrost has got methane hydrates, and you raise the temperature of the methane hydrates, they decompose, and methane starts to emerge. So the question is whether there's going to be an explosion of methane from that region. This is from a paper published about 5 years ago showing the total sea level rise that could be anticipated with the temperature rises above the level it was at in 2015. Right, so that's not since the pre-industrial period. And we see that with a 1 to 2 degrees centigrade temperature rise above where we were in 2015, we can see this irreversible melting of the Greenland ice contributing to a 7-meter additional sea level rise, additional to other ice melting, for example, on the Himalayas, and in addition to the expansion of the water as it is warmed up. So what this is showing is that the map of the world would be changed very dramatically if we get into this area. I'm not talking here about the Antarctic, but there are some pretty worrying things happening in the Antarctic region as well. Now, I said the worry is that the methane would explode, and until a year ago, that was all I could say about methane emergence. And then I went to a meeting in Reykjavik of heads of government and others from the Arctic Circle region in October last year. And there we had a presentation from the Russians. The Russian scientists were told by their government that people in a small town on the permafrost up in the northern region of Russia were reporting very large explosions. In fact, the people in the town thought that the Russians were testing new weapons. All right, so here's a photograph of what they actually saw. So what you can see here is the person who presented the talk had the camera. This is his shadow. He's standing on the rim on this side, and his colleagues standing on the other side. That is about 50 meters diameter. It's about 100 meters deep. It's very strange. They've actually managed to photograph one of these beginning, and the permafrost starting level turns into a big bulge, and then it explodes. Now, they estimate there are something like 2,000 of these, and each of these explosions is the emergence of methane, which must be trapped under the ice, forming pure methane gas, which reaches a high enough pressure that it blows the ice away. And there's not much residue around, right? So most of it is ice and methane that ends up in the atmosphere. Methane is at least 22 times the risk of causing climate change compared with carbon dioxide. So this is a worry. And the question is, what do we do about it? These are this region of Russia is Yamal, and Yamal is now forming these summertime lakes, and you'll see the holes that are formed in that area. These are some of the 2,000 holes that have formed so far. So it's not something that's going to happen in the future. This is happening right now. So there's another way of looking at this. We can take the climate science, which is, I think, extremely sophisticated, and see what the temperatures are likely to be in the future. Or we can just look back in time and ask a simple question. If we take the lower curve, we know, by the way, that that curve is way out of date, 400 parts per million in 2017. If we take the lower curve, 410 parts per million where we are today, and ask, how far back in time do you have to go to match up to that sort of level in the atmosphere? And the answer is about 30 million years, when the temperature was 7 degrees higher, 10 degrees higher than today. We don't know accurately. These are now ocean sediment data we're looking at, less accurate than the ice cores. But these sorts of temperatures are also, of course, matched by much higher sea levels. So there's the nature of the challenge that we are with today at 410 parts per million. So what I'm actually saying is we've already passed the point of dealing with a safe future. We have to do considerably more. And so I finally come in my last few minutes to saying what I mean by climate repair. Well, this center that we're setting up in Cambridge, and Emily is one of the players in setting up the center that we're setting up in Cambridge is intended to focus on the objectives shown here. First of all, deep and rapid emissions reduction. We're not going to manage this if we don't really shift the ground on the fossil fuel to fossil fuel free future that we need. But secondly, we need to look at how we can create large-scale carbon dioxide sinks. And when I say large-scale, I mean in excess of a gigaton a year, a billion tons of carbon dioxide a year. We're looking at 10 billion tons a year that we need to remove, remembering what levels we're at the moment. Right? So that's a big operation. Many ideas have been put forward, but what we would like to do here in Cambridge is see that we work on each of these ideas, work out which of them are scalable up to the large dimensions required, are also not too expensive to run, and have no known deleterious effects. So we need to sort all of these things out in a university of this standing so that we can help determine the way forward. So the objective there is to restore the atmosphere to 350 parts per million or less. So we're at 410 today. We need to be pulling it down. If we continue to emit, of course, we can never manage that. So we've got to get to net zero emissions, and we need to be removing carbon dioxide from the atmosphere to bring down the levels. And then you see item 4. I believe we also have to refreeze the poles, and in particular the Arctic. In other words, I don't think we can wait until we bring the global temperature down to the level where it refreezes itself. I think that process is going to take quite a few decades, and already we're seeing the risks of the Arctic Sea appearing and the challenges that poses. Now, this is a big challenge to every scientist and technologist, but also to social scientists, economists, the humanities. We're all involved. And so this center is attempting to pull together an academic community across Cambridge to work on each aspect of this challenge going forward. Why do I say it's not just science and technology? It's no good just putting forward the solutions. We need to roll these solutions out globally, and we need to roll them out quickly, and that's an area where social scientists, economists, and others, humanities and arts, would need to be brought into play. I'm just going to quickly, as I finish, talk about just one intervention on refreezing the Arctic. There's a marine engineer up in Scotland by the name of Salter who has been working on this for a while. He's produced very detailed designs. If you pump seawater up into the higher atmosphere, and if you pump it up through a sieve so that it sprays the water up, as the water droplets go up, the water evaporates, leaving single salt molecules, sodium chloride molecules, in the atmosphere. And as they come down, if there's cloud cover below, they will start renucleating water around each individual sodium chloride molecule, which creates, of course, very small droplets. And small droplets in a cloud are white. Large droplets are black. So what we need is to whiten clouds and have those clouds heading towards the Arctic region or being in the Arctic region. So the idea is to create white cloud cover over the Arctic region in the Arctic summer. And these floating arrangements here are Salter's clever idea. These large cylinders are spinning. And basically, when you take a cylinder and spin it on its axis, you create an upward force on the cylinder, which pulls the water up, and you blow that through a filter. And the estimated cost of running this, it's amazingly cheap. We're talking about a few $1 billion a year to keep this going. Of course, once we've started, we have to keep going until the whole planet temperature has come down. But that's certainly going to be much cheaper than putting up with all of the challenges of rising sea levels. Now, when we talk about removing carbon dioxide, we, of course, are looking at reforestation as a major program of work, but with the population of the planet heading towards 10.5 billion people by the end of the century, we're going to need a large amount of land mass for food production. So while there is still an enormous opportunity for forests to be recreated on land, we also need to be looking at regreening or greening the oceans, which are 72% of the Earth's surface. And we would only look at the deep oceans, the Atlantic, the Pacific, because what we need to do in greening the oceans is make sure that when the green material dies, it sinks into cold water below. So it's got to be deep oceans. All of this it needs to be checked out. It looks very promising because you can do it very cheaply as well. And you can potentially store billions of tons of carbon dioxide in the ocean floor in that way. You can also create seaweed and kelp, which has obvious human implications, in the shallower waters by stirring up the seabed and pumping the nutrients from the seabed up into the sea level. Once they're up in the sea level, the kelp and the seaweed appears. So it's a relatively self-making process. So these are all the ideas that we plan to examine here as we move forward in time. I'm going to finish this by complimenting the Chinese government and the Chinese people for coming up with what I consider to be the most important notion backing what we need to do. I've been very fortunate in being invited back to China every year. I'm a visiting professor at Tsinghua, but it's the Chinese government that bring me back. And they have changed their constitution to include what they call the scientific principles of development. And in that, they introduced this word, eco-civilization. Eco-civilization, and it's all spelt out in their policy statements and in the Chinese Communist Party agenda. The eco-civilization means managing ecosystems, the well-being of ecosystems alongside the well-being of humans. And what they are saying is you can't manage human well-being without making sure that you look after the ecosystems as well. Now, I think that's a broad-based position that we need to adopt in order to find our way through this century. Thank you.
Thank you very much, David. We now have about half an hour, well, maybe a bit less than half an hour for questions. And it's a packed audience, and we also have people sending in questions online. So if I could ask, first of all, there's some microphones. I think. Are there around the place? Yes. So if you could wait for the microphone when I point to you, and if you could possibly keep your questions as brief as possible, then I'll try and get as many people in the room to ask questions as I can. So who would like to start off with the first question? Over here? I'm going to sit down here.
When you're thinking about the amount of CO2 that we need to take out of the atmosphere to get us back to your 350 ppm, I understand that the ocean is one of the largest stores of CO2, I think the number's something like 400 times as much CO2 as in the atmosphere. And as it warms, as the global temperature warms, that tends to degas. So would it not be the case that we need to subtract from the atmosphere not only the contributions that we are making of CO2, but this enormous additional amount of CO2 that's coming out, presumably from the atmosphere, as your models show that from the oceans, as your models show that the temperature is rising? And what sort of a number in gigatons of CO2 would we therefore be talking about to try and dispose of?
And one of the additional problems with the uptake of additional CO2 in the oceans is the acidification of the oceans and the damage that is causing to the ocean systems. So whatever we do, we have to look at reducing the carbon dioxide content of the oceans. And when I say reducing, of course, I mean converting it into a stabilized material that sinks to the bottom of the oceans. We need to be generating a system that will take carbon dioxide out of the water and out of the air. And of course, the surface water is roughly in equilibrium with the atmosphere, so as you take out one, you take the other out as well. And one of the advantages, let me just say a quick word about greening the ocean. If you take the Sahara Desert, and a wind blowing over the Sahara Desert over the west coast, when the wind stops blowing, it drops sand onto the ocean surface. And wherever that happens, you get a big greening of the ocean. And that greening, of course, is catalyzed by the iron content of the sand. And the chlorophyll formed creates algae. You then get a mass of fish appearing in the same region. It's a forest in the ocean. But eventually that does die, and as it dies, if the water's deep enough, it drops through that 100-meter region where the water's moving to the more stationary and colder water below. But that algae is taking carbon dioxide out of the ocean as well as out of the air. So it is performing both tricks at once.
Can we get the mic? Thanks, Hugh.
So, given the evidence about climate change, from your experience, why is there so much skepticism about climate change?
Why is there so much skepticism?
Yeah.
All right, so I mentioned that the United States has been problematic, and one of the questions you could ask is, why does the vast majority of senators and congressmen in the United States vote not to take action on climate change, whereas the British Parliament voted unanimously to take action? And I think the answer is the American lobby system, which is amazingly successful. So let me name the Koch brothers, who own much of the coal deposits in the United States, but they're into oil and gas as well. They have been funding, and we don't know the precise estimates, but let's talk about $500 million a year going into the lobbies and the campaigns against climate science. That really has been very damaging.
So, David, just following up on that. So, one of the things that you stressed in your talk was how you felt that the United States, in particular, had been quite a drag over decades, frankly, in terms of driving forward action on climate change. I mean, in your view, what do you think today are, who is showing leadership in terms of countries in terms of climate change now in the post-Paris era?
Well, I wish I could still say the British government. I mean, what is interesting is, I'm coming back to your question, but when I was brought back into the Foreign Office by Cameron, and then I served with May, and my boss was a man called, you've probably heard of, Boris Johnson. But when I came back into government, what I was told by Prime Minister and Foreign Secretary, you're a talking voice, you're a talking head. We need people to hear what we're doing about climate change. I was never given permission. So whereas with the Blair and Brown governments, I was on television and radio frequently, I was never given permission to appear. So why doesn't anyone know about the International Climate Fund at £9 billion? The Green Climate Fund in Seoul, which is the international fund, we put $1.2 billion into that, total $11 billion from the rest of the world. We had easily the biggest fund. And Cameron was the person who created that, but I was never allowed to say that in the public domain. Now, you're asking why, and I went in eventually to the number 10 communications office, and I was told, you go out broadcasting and boasting about what we're doing on climate change, the Sun and the Daily Mail will run a campaign, and we will have to stop your funding. That wasn't the Prime Minister. That was head of communications. So it's the strategy for keeping government in power, driven by this communication leader, that was really the factor. I'm sorry, Emily, did I answer?
No, you didn't answer my question. I'll come back and ask you again. But there's another question in the middle here. If you can pass the microphone along.
You discussed the sea level rise and, in turn, warming. That has an effect on sea life ecosystems. Is this effect irreparable, or is there a stage where we can halt it and maybe reverse the effects? Yes.
It's always been reversible in the past, right? In the sense that the warm period ice age oscillations have been reversible, and I don't see why it shouldn't be reversible in the future. But the question is, what is the time lag on that process? And I think that we can't wait a few generations of human beings for this all to come about. So I think trying to reverse sea level change is going to be a fairly long-term process. More important to me is, you might have read the recent publications on the Himalayas, and basically the loss of Himalayan ice is going to be enormously challenging to the countries around that depend on the runoff for creating their crops. And I'm talking about China, India, Bangladesh. All need the runoff from the ice. So there are, and that's relatively short term. So it's, I mean, what is interesting is, whatever technologies are developed for refreezing the Arctic, we could also use, I think, in the Himalayan regions or other regions as well. So I think let's get on with the technology and then see if we can roll it out.
Where's the... Oh, sorry. Yeah, off you go.
Professor David, thank you very much for your talk and for all the work you've done in this area throughout your career. This movement of techno-optimism concerns me. I unfortunately do not. I unfortunately do not necessarily share that optimism, and I'm not convinced that we can invent our way out of this problem. Even if we do invent our way out of this problem, I'm not convinced we can implement change at the rates required to meet our targets. So I therefore think we need demand-side reduction, behavioural change, where people use less energy in their lives. use less heating, travel less, these sort of things. Do you agree that demand-side emission reduction is important to tackling these issues? And if so, what message would you send to society about ways in which they can do it most effectively?
So I think emissions reduction, as I said, that's number one in our climate repair agenda. And you're stressing demand side reduction. And I would say the important thing is reduction. I'm not going to persuade the countries of Africa to cut down their demand on energy usage. So I don't think that there's an awful lot we can do on the demand side. However, human behavior is critical. So I totally agree with the notion that each one of us is responsible, each one of us should be reducing our demand for energy, because today the energy is produced by fossil fuels very heavily. So I agree with that. But let me just say this, no technology solutions, okay. Let's suppose we cut down tomorrow to 0 emissions. So we stick at 410 parts per million. What are we going to do about the melting of the Arctic, rising sea levels? All of these long-term things are already in train. And that's my main point, that we need these technologies to come through. I'm now of the view that, in a sense, the problems have been created by science and technology, but I'm also of the view now we need technology to provide the solutions. So we may or may not agree on that.
Thank you.
Can I just follow up? I've got a whole set of questions that have been sent in online. So, but let me sort of spread them out. But this one relates in part to that, which is asking the question really about whether or not the timescales, either for technological innovation or for social and political change, are just too long to be able to repair the climate on the sort of timescales that you were suggesting was required. So you know, is this really feasible?
I don't know. I mean, here's the problem, because you're looking at an optimist. I have been beavering away for the last 20 years, largely from within government. I'm still working with governments around the world. And all of my effort has been with the belief that we do have the time to manage this. But are we close to running out of time? Remember, I began by saying what we do, what we continue to do, what we begin to do over 10 years is going to determine the future of humanity. Now, that doesn't tell you that I believe we've got a lot of time.
Okay, question over here.
I was encouraged by your comments about the Chinese eco-civilization concept. Since China has probably the largest footprint on the global oceans in terms of its fishing fleets and consumption of fish, have you heard any? Have you had any hint that the Chinese government might engage in ocean restoration projects to regreen the ocean?
Well, that's a very good question. I mean, if you'd asked me about their production of renewables, you know, they're world leading in solar energy, wind turbines, world leading in nuclear energy, all of these alternatives to fossil fuel are being rolled out. Their coal-fired power stations are now down at 35% operation because they're cutting back on coal usage. So they, in many ways, are behaving well. I don't know the answer to your question. We'll have to ask the Marines. Yes, I will ask them next time I'm there.
I'm going to ask another one of the questions that came in on Twitter, which is that, so you focused a lot on, in terms of repairing the climate, on ways of taking carbon dioxide out of, actively taking carbon dioxide out of the system. But equally, you showed those horrendous craters from the Yamal and raised the very concerning aspect of methane, a much more powerful greenhouse gas than carbon dioxide. So are there any technologies that you're aware of that are looking at taking methane out of the atmosphere rather than carbon dioxide?
No. No. I mean,
I mean, some of the answer is that the chemistry works in the favour of turning methane eventually into carbon dioxide anyway, I guess.
Yes,
but
so methane, I was just going to say, is highly reactive.
Sorry, John.
So,
maybe I can answer your question on leadership as well.
we could farm the methane. And by the way, 3 out of 4 of the Russians who were present at the Arctic Circle meeting were people who were interested in benefiting from the methane by capturing it and feeding it into their financial system. But of course that doesn't remove the problem. You're going to burn it, create carbon dioxide, which is less of a challenge than methane. But there's a very big problem, because dealing with explosive emissions is very, very challenging. So I think that the answer is, if we look at the way we farm, methane production from rice paddy fields, very heavy. Methane production from all of the animal production that we have, very heavy. And in places like New Zealand and Denmark, they're most advanced in capturing methane. Cattle in sheds, they capture the methane emitted and use it as a fuel. But everyone is converting methane into a burnable substance, whether it's an alcohol or just burning methane. So it's not exactly a solution.
Right. Question down here.
Thank you very much. I believe very strongly in the power of the living alternative, and also can we put equity at the heart of tackling climate change. So I wondered if you could tell us a bit more about Rwanda, because I just thought that sounded a really interesting example.
Gosh, I can be very boring about Rwanda. I mean, basically I'm working there with the most visionary president I know in the world. I mean, if we talk about world leadership, he's just spent a year as chairman of the African Union. And he spent that year getting the business of removing trade barriers between all African countries, right? And he got agreement in principle. At his very first meeting in January last year, he got agreement in principle from all but one head of government. That was Nigeria. But even South Africa and Tunisia, all of the rest, voted for removing the trade barriers. So he's a very forward-looking character. And for him to bring me in as his senior strategy advisor is to say to the world, we are going to demonstrate that we can green our economy, and we will grow it even faster as we green it. Now that's him saying we can demonstrate to other poor countries that this is a transition that needs to be made and can be made. So his country is only 11 million people, but the impact that he's already having across Africa is enormous.
What have they done, sorry? What concrete measures have they done?
Okay, so basically solar energy is rather plentiful in Rwanda, and so running, for example, we've got a program at the moment to see that 520,000 off-grid houses, which have never had electricity, will all have photovoltaics and batteries installed by 2021. Now, that program is helped with funds from DFID and from USAID, but always the way it operates in Rwanda is upskilling people. So it's all done through companies that are developing the photovoltaic technologies, not making the photovoltaics, but installing, selling, maintaining the photovoltaics on rooftops. So it's working through the private sector to see that it rolls out quickly across the country. But I'm pretty confident that 500,000 houses that haven't got electricity today will have it. We're focused more on off-grid houses and villages than on the on-grid, but that of course has got to be the next part of it. Secondly, Volkswagen are now producing electric cars in Rwanda. Right? So what we have is a policy of removing all petrol and diesel-driven road transport vehicles. Now I mentioned the air travel, at least for freight, is initially going to go over to these airships. That will be, again, economically transformative. Right at the moment, if you bring petrol, diesel, over from Mombasa to Rwanda over the mountains, it ends up as the most expensive petrol in the world. Right? Whereas if you pick up whatever you need from the ships in Mombasa Bay, fly it over with these airships driven by photovoltaics, and deliver it to where it's needed, you're cutting back on costs massively. So I think that many, many things are happening. Let me leave you with this one thought. The country in the world, I'm quoting now the WHO, with the highest level of uptake of vaccines for children is Rwanda. They estimated 98% of small children are vaccinated in Rwanda. And of course what this means is that child mortality has collapsed in the country. Population is growing quickly.